Thursday we go. Do you have any query? Hello. Can you hear me?
Yes, sir.
Okay.
The voice is very low.
Voice is low. Okay, okay. I'm checking. Now is it okay?
Yes, sir.
Okay. Uh, Last day we discussed about the proof of master theorem. Do you have any query?
No, sir.
Okay, so we can go to the next point, right? Let us start
Yes, sir.
there. Hmm. What is going on? Okay, can you see the screen?
Yes, sir.
Okay, so today we will discuss the algorithm to find the max and min of n elements. Okay, so let an array is given. The array is containing n number of elements, and we have to find the maximum and also the minimum by the same algorithm. Okay, so what we can do, the first of all, the first answer or the first algorithm that comes in our mind is number one, sort the element, sort all the elements, n elements, maybe in ascending order, okay, ascending order, and choose the first element as the minimum and the nth or the last element as the max. So that will be the easiest method for us. That means easiest in the sense it will come first in our mind. That let us sort in ascending order and then choose the first element as the minimum and the nth element as the maximum. But the thing is that later we will discuss about the quick sort algorithm and the time complexity of merge sort algorithm that we have learned. Let we are applying the best sorting technique, and all of we are aware that it is of order n log n. So you will not be able to sort n number of elements. Obviously, sort means we are considering the generalized input, not any define or any constant or constrained elements. Okay, so that means some properties are assumed or something like that, which are used in radix sort or counting sort like that. So we are considering the general input. Therefore, the time complexity of any sorting technique is order of n log n. So it will not be possible to find the maximum and minimum with the less time complexity than n log n if you go for using what any sorting technique. But here our task is to find the algorithm which will take less than n log n time, and it will be better. That means since maximum and minimum finding algorithm is a process of searching, nothing else. So our target should be to find an algorithm whose time complexity will be order of n, not greater than order of n. So therefore, n log n is larger than n, and we should not use the method of sorting. So searching can be done at most by n number of comparison, that is order of n, not n number of comparison. But here, if you apply sorting technique, then it will be of order n log n. Therefore, we will not consider sorting as a good option for searching maximum and minimum of n number of elements. Okay, so let us forget this, that we will not go for sorting the list. Then what we can do? We can find the maximum of n element by using a very known algorithm like this. So suppose max is our function, we have to find a, the array is a, and n is the number of elements. So what we do? We go for a loop for I equals to 2 to n, let, and here we consider max equals to a1, let our array is from 1 to n. Okay, you can consider for 0 to n minus 1 also, there is no problem. So we are considering the first element as the max. Then for I equals to 2 to n minus 2 to n, what we do? We consider if a I, that is the next element, is greater than max, then we substitute or replace the value of ai with the max. Okay, and if we go on repeating this one, finally after the for loop we can write that print max. So it will give the maximum element, that all of you are aware. Similarly, for the minimum element, to find the minimum element, simply what we can do, we can just write the function as mean, then this, and for here let us consider mean equals to a1, for I equals to 2 to n. If ai is less than mean, then what we do? We replace this value mean equals to ai and print minimum. So by two separate algorithms, we can find the max and we can find mean. Okay. So these two are very common and we are aware of this algorithm. So if we combine both the algorithm, then what we can get? We can get the solution. There is no problem. So what we can do? Let us first write the algorithm max mean 1. So this is the first version. Later we can find, if we find some better algorithm, then we will write max min 2 or so on. So here we are passing an array of elements, say a, and there are n number of elements in the list. Okay, so we are considering max equals to mean equals to a1. The array is a 1 to an. Okay, we are not considering from 0 to n minus 1 or something like that. So max equals to mean equals to a1, we have considered this. Next, for I equals to 2 to n, for I equals to 2 to n, we can write if ai is greater than max, then max equals to ai. Okay, so from here we can get the maximum value. If we repeat this, if ai is less than mean, then we can find the mean equals to ai. So by using this, if AI is greater than max, then max equals to, this is equals to AI, and if AI is less than mean, then mean equals to AI. So if we go on repeating this, and after that if we print max and mean, we will get the value of maximum and minimum from the given list. Okay, so I think there is no doubt that it will the algorithm will execute properly and we will get the correct output. Okay, so I'm not going for any examples, or this is very simple one, everyone knows it. Now the problem is, or not the problem, the question is that what will be the time complexity of this algorithm? Time complexity of the algorithm Tn is equals to, here you see this is assignment statement, so we are assigning two assignment statement we are using, therefore this is equals to 2, right? And here for I equals to 2 to n, so that means it will execute for n minus 1 times, the whole thing will execute for n minus 1 times, and there are two statements 1 and 2, so therefore we can write the whole for loop will execute for 2 into n minus 1 times. So therefore the time complexity of max min 1 is equals to 2 into n minus 1 plus 2. Okay, and what we can say, the number of comparison, actually we are talking about the what is the number of comparison required to find this, is equals to 2 into n minus 1. So we are considering, or we are concentrating on this number only, 2 into n minus 1. Okay, now the question is that is it possible to decrease this value? Let us check that whether it is possible to decrease the value or not. First, let us try to find that what is the unnecessary things or the redundant task that we are doing here. Check. Max equals to mean equals to a1, so we are assigning the first element as the max or mean, these two variables. Now we are checking that if ai, that is the next element, a2 is greater than max, suppose this condition is true, let, if this condition is true, will it ever execute this statement? This statement will never execute throughout its scope. So that means once the first condition is true, it will not be executed. Executed means here obviously it will be executed, but it will never become true, because since it will never become true, therefore it is optional. So therefore if the first condition true, then we don't have to check the second condition, because at the same time ai, the same element, will not be greater than max, and at the same time will not be less than mean. So any one of these two conditions will be true at once. Okay, so therefore instead of if we can replace this loop by else if, then I think our task will be much more easier, and uh, the time complexity may be less than this. Okay, so let us check for the next element. So please keep this mind that our comparison, number of comparison required to solve the problem is 2 into n minus 1. Okay, we are not talking about the time complexity or the bound or something like that, because if we go for bounding all these, then everyone is a polynomial of n, but here we are considering the number of comparison required to solve the problem is 2 into n minus 1. So keep this in your mind. Okay. Next, so here we have found that unnecessarily we are doing something, so it can be overcome, and let us write the algorithm in some different way. Okay, so here we are writing max min 2. Again we are considering a n, number of elements n. So considering max equals to min equals to a1, max equals to min equals to a1. Then for the same thing, I equals to 2 to n, if ai is greater than max, then max equals to ai. Else, okay, else if ai is less than mean, then mean equals to ai. So if this condition is true, we know that it will never be true. But if this condition is false, it may be true, it may not be true. Okay. So we have to check this. Now put this value, and here you can write print max and mean, which is not the part of our algorithm, but still we are writing for an output. Okay. Now what will be the time complexity? Time complexity means let us find the number of comparison required. Okay, how many comparison is required to solve the problem. So here you see we are having two different cases. Number one, let the array is in ascending order. The input is in ascending order. Then what will happen? Every time this condition will be true. For all the execution, the first condition will be true, and we don't have to go for the second checking. So at most, when the input is in ascending order, think it, try to visualize when all the inputs are in ascending order, every time in every execution the first condition will be true, and since the first condition is true, we don't have to execute the second statement. So what will be the number of comparison? N minus 1. Okay, so we can write that when we are sending the ascending order input, the number of comparison required to solve the problem is n minus 1. Now just think about the next case. Let the array is in descending order. Then what will happen? First we will check this condition. Okay, this is false because ai, the first element, is not greater than max, because descending order means second element is less than this. So the second element is not greater than this, therefore it is not true. The first condition is not true, hence you have to check for the second condition. So here if we check the second condition whether it is true or not, yes, we will find that for each and every execution the second condition is true. Therefore we have to check for the first condition n minus 1 times, and also the second condition for n minus 1 times. Right? For every execution, that is for each iteration, we have to check both the conditions when the array is given in descending order. Therefore we require again 2n minus 1 number of comparison when it is in descending order. So we are getting two cases. One is best case, we can say, and this is worst case, which is 2n minus 1. Now see, by replacing the statement with else, we can get the best case, which is n minus 1, but again in worst case it is taking 2 into n minus 1. So though in some cases the time complexity will be less, but in some cases again, okay, the time complexity will be same as the previous. Clear? So therefore, now our task is to find an algorithm, okay, right here, an algorithm so that the average, on an average or in general, the number of comparison is less than 2 into n minus 1. So that means what we can say, in random cases, or the expected number of comparison or the time complexity is less than 2 into n minus 1. So let us find that if such an algorithm exists or not. So here you write, we are finding the best case with n minus 1 number of comparison and worst case with 2 into n minus 1 number of comparison. Okay. So this is the second algorithm that we have learned to find the maximum and minimum of two elements. Okay. So then let us go for another version of the algorithm, or modified or updated, whatever you can say, and let us try to find the algorithm or design the algorithm so that the average time complexity is less than 2 into n minus 1. Okay. So to solve the problem, we will apply divide and conquer method. Hope all of you are aware about the term divide and conquer. Later we are having some more discussion on this divide and conquer method, but here just for a revision of your previous data structure class, divide and conquer means first we will divide the problem into some set of sub problems. We will solve the problem, sub problem, sorry, not the problem. We will solve the sub problems and collect the solution of the sub problems to find the solution of the problem or the given problem. Okay. So since we are dividing first and then we are conquering or adding all the solutions, therefore it is termed as divide and conquer method. So here we will apply this technique to find the solution of finding max and mean problem. Okay. Right. So later I will give an example. So first, let us write this, or I think let us first go for some example that will be better to understand, because the algorithm is written in the book, or I can write it later also. So let we are having this as the given array 15, 60, 18, 30 and 40. So let how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 elements. Okay, there are 9 elements and we have to find the maximum and minimum of these 9 elements. So from here we can find that 60 is the maximum and minus 9 is the minimum. So we have to find these two values from the list. So what we can do? So first we can divide the list into two halves by adding, let this is 1, the index is 1 and this index is 9. So we are considering that it will be divided into 1 plus 9, 10 by 2, that is 5. So we will consider a sub list with 20, 10, minus 5, minus 9 and 15. Okay, and another is for mid plus 1, that is 60, 18, 30 and 40. Okay, So the given list is being divided into two halves. One is 10 by 5. So we can go for this 5 and this is 4. Then let us divide this again into two halves with I is 1 and n is 5. Here the I is what you can say 6 and this is 9. So 1 plus 5 means 6, so 3. So 1, 2, 3, we can divide this as 20, 10, minus 5, and here we can write as minus and 15. So this is 1, this is 3, this is 4, 5. 6 to 9 is being divided as 6 plus 9, 15 by 2, so 7.5 means 7. Okay, since we are considering the floor value. So therefore 6 to 7 is 60, 18. And here we are getting 30, 40. Okay. So we will go until each sub-array contains one or two elements. So here all these are containing two elements except this 3. So we can divide this into two halves. One is 1 plus 3, 4 by 2, that is 2. So 20 and 10, and this is minus 5. Okay. So this is 1, 2, and the array index is 3. Now, what are you doing? We are finding the max and mean of these arrays. Okay. So here what we are getting, if we find the max and mean, so just we will compare these two elements 20 or 10. The lesser value will be considered as the minimum and the higher value will be considered as the maximum. So in this case this is considered as max and this is considered as the mean. And here since there is only one element, therefore max equals to mean equals to minus 5. Think about that. So this is max 20, this is mean 10. So here what we will get? This is minimum and this is maximum. So let us write this 9 and this is 15. Here also max 60, mean 18. This max 40 and mean 30. Okay, right? Mean is 30. Now from here we have got the max is 20, mean is 10, and here we have got max and mean of these two. Now let us compare the max of the first sub-array with the max of the second sub-array. What we will get? If max is greater than this max, then the maximum among these two is this one, or what we can say, the maximum value of these two sub-array is the largest element among the maximum of these two. So here 20 is max and minus 5 is also the max of this sub-array. Therefore if we compare these two max, we will get that 20 is the maximum of these three. 20 is the maximum of these three elements. So we can write that max 20 is the maximum of these three. And let us compare minimum with the minimum value of this, and we will choose the lesser value as the minimum of these three. So from here what we will get, 20 is the max and minus 5 is the mean of these three. Clear? Now let us compare the max of the first array with the max of the second array. And if we compare these two, we will get 20 is the largest value, and we can say 20 is the maximum of these 5 elements. Okay, so we can say that 20 is the maximum value among all these 5. Similarly, if we check the minimum of the first subarray with the minimum of the second subarray and choose the less value as the minimum of these 5, then we will get -9 as the minimum. So from the first left hand subtree, what we have got? We have got max equals to 20 and mean equals to -9. Similarly, from the right hand side, what we can get? We can find that 60 is the maximum of the first subarray and 40 is the maximum of second subarray. So if we compare these two, we can say that 60 is the max of this 4, and if we compare the minimum these two values, then we can find that 18 is the minimum of these 4. Now, if we compare the max with this max and mean with this minimum, then we can find that 60 is the maximum of these 9 elements and -9 is the minimum of this 9 elements. So that was our target. So by applying this divide and conquer method, we can go for finding the max and mean of this given element. Okay, so let us write the algorithm. I think you have understood. If you have any problem, so just after my discussion, you can ask me, no problem. So let us write the algorithm first. So max and mean, here we will first the starting index, end index, the max is the output and mean is the output. So here ij are the input, max and mean are the output. Okay. So since we are having two terminating conditions, one, the first one is that if the array is containing single element, and if the second terminating condition is that if your array is containing two elements. So at that point we can terminate our algorithm. So the if there is single element in the sub array, so we can write if I equals to j. So that means if the starting index is equals to the end index, so that means there are only one element. There is only one element. So in that case, we can write max equals to mean. Yes, max equals to mean is equals to ai. So you can write single element. Okay. Now, if there are two elements, then we can write else if I is equals to j minus 1. So specifically there are two elements. Then what we can do? We can compare both the elements with each other. If ai is less than aj, then so ai is less than aj, therefore maximum is aj, the max value is aj, and mean value is ai. So if this condition is not true, therefore else max equals to ai and mean equals to aj. End of this else if. So if there is more than two elements, if there is more than two elements in the sub array, then it will go to the else part. So else part here already we have discussed. So let us consider one variable mid is equals to the floor value of I plus j by 2, and let us call the same function max mean tree with I, mid, then max and mean. These two are the output, please. And these two are the input. We are calling the same function with mid plus 1 as the starting index up to j, and let us consider the name of the output variable as this. So max, mean, and this is max 1 and mean 1 for the second recursive call. Okay. Now, if this max is less than max 1, so that is the first value is larger than the previous one, sorry, less than the previous one, that is max is less than max 1, then we will replace, then we can say that max equals to max 1. We will replace this value. Similarly, if mean is greater than mean 1, then mean equals to minimum mean 1. So we can change this variable. So let us stop this else, and after that we can just send this variable to here, and we can get it print from other function. So this is the algorithm that we had discussed just with an example, okay, to find the max and mean. So here this is giving the condition 1 that it is containing single elements. This condition is giving that the list is containing 2 elements, and these two are the terminating condition. And here this one is giving us that the subarray is containing more than 2 elements. Okay, containing more than 2 elements. So again you can recollect your example that first we are dividing this into, for our previous example, what we did, we had considered I as 1 and j as 9. So we have got mid value as 5. Hope you can just recollect your memory. And we have called the function with 1 to 5, and here we have called the function from mid plus 1, that is 6 to 9. Okay, and from here we have got some we want to get some max and mean, and again this max mean will be iterated from with the value 1 and 5. So again we will get 1 2 3, and from here 4 to 5. So this value will be again 6 to 7 and 8 to 9, just like the previous one. Okay, so again this 1 3 will be divided into 1 2 3 and this 4 5. So next, if max is less than max 1, so here 4 1 2 will be compared with 3. Already we have given the example. 4 5 will be compared to find the max and mean, and after that these 3 and 2 5 values will be merged, not actually merged, the sub problems will be merged, and here also these two sub problems will be merged to get the solution, and finally the whole list will be merged to get the solution of the same problem. Okay, so this is the algorithm. Now the question is that what is the number of comparison required to solve the problem? So that is the question. Okay, so let us erase this. If I erase, then it will create a problem. So I am erasing a part of this because I need some space. Okay. Right. See, here we require a constant time because the number of comparison and the assignment statement is 1. So this is also we are considering this is a constant time. Here also, what are we doing? We are require a number of comparison, that is 1. Okay. Here, how many comparisons are required? If we require n number of comparisons to solve the max min, or let Tn is the number of comparison for the algorithm max min. So we are calling the same function twice, one with T of this much of input, another is with this much of input, and these two for the conditions for single element and for the two element, that is terminating condition. So for the sake of simplicity, if we consider that n is a power of 2, then we can write n by 2, floor value of n by 2 is equals to n by 2, ceiling value of n by 2 is also equals to n by 2. So simply by using the simplified assumption, we can write this is equals to 2t n by 2 plus, okay, 2t n by 2 plus 2. So if we go on iterating this, till we reach to that each subproblem contains 2 elements, okay, each subproblem contains 2 elements, then what we can do, we can iterate this up to k minus 1, or you can write up to I minus 1. We will iterate this up to I minus 1, and this value is t2, and here you see, first we are getting 2, in the next time it will be 2 square, in the next time it will be 2 cube, and so on. Are you getting the point? That just you consider this one. I think I should write one. Tn is equals to 2t n by 2 plus n. Just think about the iterative method that we did, right, in our last class, or maybe prior to that, and we can write this equals to 2. This is 2 n by 2 square plus, sorry, plus 2 plus 2. So check, it will be 2 square t of n by 2 square plus 2 square. So in the next iteration, what we will get? 2 cube t of t by n cube plus 2 cube. So we are iterating up to n by 2, not up to that 1. Okay, so up to we are iterating the terminating condition up to 2. So it will be stopped at 2 I minus 1, and this one will be sum of 2 to the power it will be up to k minus 1. So if we write this, it will be equals to, you see, t2 is terminating condition, therefore constant. We can write this is 2 to the power I minus 1 plus sum of 2 to the power I, or this one we can write as, this one we can write from the series GP series, that 2 to the power k, that is 2 to the power r to the power n plus 1 minus 1. So here we are having k number of terms, so therefore it will be 2 to the power k, okay, 2 to the power sorry, here if we write this value, let's write k, so that will be better. We are terminating this up to k. So 2 to the power k minus 2 by 2 minus 1, and here we can write this is k, since we have considered n equals to 2 to the power k. So that's why we are considering oh sorry, I am without writing this as I, since we have considered n equals to 2 to the power k, so let us start execute this up to 2 to the power k minus 1, and this will be t2, this is 2 to the power I equals to 1 to k minus 1. So therefore it will be equals to 2 to the power k minus 1 by this. So that is equals to 2 to the power k minus 2 by 1. So this value will be equals to 2 to the power k minus 1 plus 2 to the power k minus 2. So what is this value? 2 to the power k minus 1 is n by 2, as n equals to 2 to the power k. Therefore 2 to the power k minus 1, that implies 2 to the power k minus 1 is equals to n by 2. N by 2, 2 to the power k is n, and this. So that is equals to 3n by 2 minus 2. So here we can write the time or the number of comparison required is equals to the number of comparison required Tn here is equals to 3n by 2 minus 2. Obviously this is less than 2n minus 1. Maybe for some cases that is equal, but this is less than 2n minus 1. So we have got an algorithm where in average case, that means we do not know whether it is ascending order or the descending order. So in average case, the time complexity is less than 2n minus 1. So here time complexity, we are not finding the bound, we are finding the actual polynomials or the number of comparison required. Okay, you can say that, sir, since we have learned that 2n is equals to big O of n, similarly 2n minus 1 is also big O of n, similarly 3n by 2 minus 1, sorry, 2 is also order of n. Yes, you are correct. That the time complexity or the bounds for all these are same, because all these are polynomial of n. But the actual number of comparison we are finding, therefore the third one is the best among all the three algorithms that we have studied, because in an average case the number of comparison required is less than 2n minus 1. Okay, so when the n value is very large, the number of comparison will be required very less than the previous two. Clear? Now do you have any questions now? Any doubt?
No, sir.
Okay, so I should give you one home task. So this is given in your syllabus, that write an algorithm or to find the second largest of n elements. Okay, this is your home task. So later I will provide some more assignments, but this is within your syllabus, that too you have to find the algorithm which will find the second largest of n elements. I will not discuss this in your class. So you have to find out, you have to search the algorithm and you have to read it by yourself. If you find any difficulty, then you should ask me, I will discuss it in the class. Okay, otherwise I will assume that this has been discussed, and obviously you will find the algorithm by yourself. Right? So let us stop today's class. If you have any query or any questions, later you may ask. Okay.